Now, we've been working on this evaluating logarithms problem, and hopefully you've now tried this assignment, but we're going to go ahead and go over it. So this first page, hopefully you're all right with, but if you look at the second page, problem 25 I went over in my video, but 26, we have the log base 2 of 2 to the x. Now, I recommended that you rewrite this, so notice how my base is 2. So I'm going to say 2 to the what power equals this thing inside of the log, which is 2 to the x. Well, if my bases are both 2, that means my exponents should also be equal, which means inside the box I would need to put an x, which means the answer to problem 26 is x. Now on problem 27, we have 4 to the what power equals 16 to the x. Well, notice how this time the bases are not the same. But I do know that I can rewrite that 16 as 4 to the second power. So now I have that 4 to the sum power equals 4 to the second to the x. Well, then I remember that when I have 4 to a power, I multiply those powers together. So this becomes 4 to the 2x. So now my problem reads 4 to the what power equals 4 to the 2x. Well, now if my bases are the same, that means the exponents would also have to be equal. So in the box, I would fill in 2x, which means my answer here on 27 is 2x. Now on 28, I asked you to put these numbers in order from smallest to biggest. So to do that, I can just go ahead and figure out what each of these numbers means or equals. For example, 28, the first problem I have is log base 3 of 81. So I can think of this as 3 to the what power equals 81. Well, if I pull out my calculator and just play around with it for a minute, I will find that 3 to the fourth power is equal to 81. So I know that that answers 4. Let's look at this next one right here, log base 4 of 1. I can think of that as 4 to the what power equals 1. Well, I know that 4 to the first power equals 4. That's too big. So if I go smaller, let's try 4 to the 0 power. Well, remember how anything to the 0 power is 1? That means that 4 to the 0 power will also equal 1, which means here my log base 4 of 1, well, the exponent it equals will be 0. Look at the next one, log base 2 of 1/8. I'm going to switch colors here so you can tell the difference between what I'm writing. So here I want to know 2 to the what power equals 1/8. Well, I know that 2 to the first power equals 2, which is bigger than 1/8. So I need a smaller exponent. I know that 2 to the 0 power equals 1, because anything to the 0 power is 1. Well, 1 is still bigger than 1/8, which means I'm going to need an exponent that's smaller than 0. Let's try -1. If I do 2 to the negative first power, well, remember how a negative exponent moves me to the bottom of the fraction? So this 2 to the -1 moves to the bottom of the fraction and becomes 1/2. Still bigger than 1/8, but we're moving in the right direction. I actually know that 2 to the third power equals 8, which means that 2 to the negative third power is going to equal 1 over 2 to the third power. But since 2 to the third power is 8, that will equal 1/8, which means the exponent I'm looking for is -3. On this last problem, log of 100, the base isn't listed. But remember how if we didn't write the base down, it's that common log whose base is 10. So I want to know 10 to the what power will equal 100. Well, written like that, I remember that 10 to the second power is 100, which means that this last answer is going to be 2. Well, once I've evaluated all of these logarithms, I can go ahead and put them in order from smallest to biggest, which I'm going to let you finish that problem. Let's talk about this last section. It says to answer the following questions. If the answer is yes, give an example. If no, explain why not. So 29, is it possible for a logarithm to equal a negative number? Well, remember how the logarithm tells us the exponent. We use it when we're looking for the exponent. So I want to know, is it possible to have a negative exponent? Well, yeah, it is. In fact, we just did it right here on our previous problem. So I can say that yes, a log can equal a negative number because you can have a negative exponent. Okay. On number 30, I want to know, is it possible for a logarithm to equal 0? Well, remember how the answer to a log is the exponent. So essentially I want to know, can I take a number, let's say 4, to an exponent of 0? And the answer is yes. Yes, I can. It equals 1, which means that yes, it is possible for a logarithm to equal 0. In order to do it, all I would have to do is the log of my base of 4 of 1, and that would equal 0. Number 31, does log base x of 0 have an answer? Well, this time I'm saying that x to the what power equals 0. Well, let's say, for example's sake, that the x is 4, and I want to know 4 to the what power equals 0. Well, if I make a table, I know that 4 to the first power is equal to 4, which is bigger than 0. So I need a smaller exponent. If I use a 0 power, 4 to the 0 power is 1, which is still bigger than 0. So let's try some negative exponents. Maybe I have 4 to the negative first power, which is 1/4. We're getting closer to 0, but we're still not there. How about a negative second power? 4 to the negative second power gives me 1/16, which is still closer to 0, but we're still not going to get there. In fact, I can keep doing this forever, and my fractions will get closer and closer and closer to 0, but they never actually get there. So log base x of 0 would not have an answer. Number 32, does log base x of 1 have an answer? Well, I'm going to do a color switch, sorry. Remember how this x is our base, so we want to know x to the what power would equal 1. Well, if I take anything to the 0 power, I know that it does equal 1, which means that yes, this does have an answer. The log base x of 1 would equal 0, because anything to the 0 power would equal 1. Number 33, does log base x of x to the 5th have an answer? Well, remember that the answer to a log is the exponent. So this is going to equal some exponent. My base is x, so x to the what power equals x to the 5th. Well, my bases are the same, which means my exponents must be the same as well. So inside the box I would put a 5, which means that yes, this does have an answer. It equals 5. The log base x of x to the 5th equals 5. Last question, number 34. Does log base 2 of negative 8 have an answer? Well, in order to do that problem, remember that this has to equal the exponent. So my base is 2, so I'm saying 2 to the what power equals negative 8. Well, I know that 2 to the first power is 2, which is bigger than negative 8. 2 to the 0 power is 1. 2 to the negative first power is 1/2. 2 to the negative second power is 1/4. And as I keep getting these numbers, these exponents smaller, my fraction gets closer and closer and closer to 0, but it never actually reaches 0. And if it's not even going to make it to 0, it definitely isn't going to make it to negative 8, which means that no, I cannot take the log base 2 of negative 8. All right, that's that assignment. Go ahead and check your answers against the answer key, which is also posted on this discussion board. Once you've checked your answers, go ahead and submit your assignment on Canvas.